Hello everyone, I hope you all are well and making progress in life. Here is Priyanshu and welcome to the Infinity Mind. So today I will be solving the problem unique paths. So the problem statement says that there is a robot on an M cross N grid. The robot is initially located at the top left corner. In the example one we can say the robot is located at the top left corner, that is grid 0 0. Alright, the robot tries to move to the bottom right corner, that is grid of m-1 n-1, and this robot has to go to this finishing point, that is the last cell, the bottom right corner, and the robot can only move either down or right at any point. Given the two integers m and n, that is the rows and columns, return the number of possible unique paths that the robot can take to reach the bottom right corner. Alright, so we have to find the number of unique paths, possible unique paths by which this robot can go from the starting point to the finishing point. So in this case we are getting the answer as 28 because these 28 are the only possible unique paths, and in example 2 also the same. So if I tell you through an example also, so suppose we have a grid of I will take a short example so that we can able to find the answer also. I will take just let's say I want to take this matrix, that is 2 cross 3. This will be easy to understand. Now robot is here, starting point, ending is this. Now what are the possible paths? Only two moves are allowed, either right or down. So we are here, we can move this point, then this point, then this point. So we can move right, then down. This is the first. Next is we can move down, then right, then right. So the second one is down, then right, then right. And the third one is first here, right, then down, then right. So the third one is first was right, then down, then right. So we can see we will get only three possible paths, not more than that. So the answer will be 3 in this case. Alright, so the grid is 2 cross 3. Alright, so we can see here answer is 3. So we have to now solve this question. How we can solve this? The first approach which can come into my mind, the brute force approach, we can try all the paths. Alright, so we can try all the possible paths. So how can we try all the possible paths? We can just use recursion. We can use recursion, and from where we are starting, we can call recursion the possible path where we can go. That is, suppose we are starting at I comma j, we can go either to I comma j plus 1, that is right. Let me write down. So if we are starting at I comma j, if we are standing at I comma j, we can either move, I should if I make the recursion tree also, I can either move I comma j plus 1, that is the right path, or the I plus 1 comma j, that is the down path. So these are only the two possible paths. Alright, so this is the right and that was the down. So now we can call recursion. If we are starting at I comma j, we can call these two paths and just ask the recursion to explore these paths and go and count how many number of possible paths are there. So this will again call next one, next one, next one, next one. So at last we will reach a point where I will be equal to m minus 1, and j will be equal to n minus 1. Basically, at last, after uh, what we say, after creating this recursive tree, we will reach a point where we will reach the ending point, the finishing point. So we will say that this is our base case. All right, and this way, if we will reach the finishing point, we will say that yes, we have found one path. So now from the ending we will just return one. All right, and we will keep returning one. And yes, we will also keep the check for the boundaries, out of boundaries. We will check that. We will add a if condition also. If we reach a point where we have reached out of boundary, we can say we will return 0, nothing else. Now, so this was very simple. We all know how to use recursion, so we can use recursion also. And but this will explore all the possible paths, all the whole recursive tree, and this will go exponentially. All right, so what we can do, if we are using recursion and we have to make it better, so we can use dp also, we can use dp array also. So we can use dp of ij to make it better. We can store, suppose we are starting at any point and again we have reached this point, any point, suppose we have reached I comma j, and if we store the answer I comma j in the dp array, so again if we are trying any other possible path and we reach the same point I comma j, we know the answer from I comma j where we can go. So we can store the answer of I comma j in the dp array. So this will reduce our time complexity from exponential to the linear time complexity. All right, so if we use dp array, then we will say that our time complexity will be big of m cross n. And yes, but space complexity of this dp array, this will be time complexity, and space complexity due to using this dp array will again be m cross n. Now we can see how we have reduced our time complexity from exponential to big O of m cross n using this dp array, but space complexity is big O of m cross n, so that's why this is not the optimal approach. And in the follow-up, if there is any follow-up, there is no follow-up. So all right, so now we will try to reduce this space complexity from big O of m cross n to constant space. How we can do this? So we can see how many possible paths are there. If I have written here for this example, from going if the matrix is 2 cross 3, so we can see that there is only 3 possible paths: RRD, DRR, right down right. All right, so we have only 2 possible moves, that is right or down. We have only 2 possible moves, that is right and down. Now if I tell you how many right moves are allowed, so if the size of the matrix here is 2 cross 3, so we anyhow we have to definitely take 2 right moves. All right, in every case we have to take 2 right moves to reach the end, to reach the finishing point. So we can see that these many moves are mandatory. These 2 right moves are mandatory for us to reach to the finishing point. So 2 right moves. All right, so 2 right moves are mandatory. And how many down moves are mandatory for us? Only one. Only one. So how we calculated this mandatory right and down moves? Just we can see if the matrix size is m cross n, so we have to reach to the end column. The finishing point is at the last column. So we can say the mandatory right moves are n minus 1. So here n was 3, so 3 minus 1, 2 moves are there. And down moves, the mandatory down moves are, we have to reach to the end point, and end point is at the last row. So we can say that we have to make mandatory m minus 1 down moves. So in this case m was 2, so 2 minus 1, 1 down moves we have to make. So from this observation, can we say that in each and every permutation of in each and every possible paths, in each and every paths, we have to make mandatory these number of right moves and mandatory these number of down moves. So yes, we can see here also there are only 2 right moves and 1 down moves. So in each and every possible path we have got 3 possible paths. So 2 right moves are there, 2 right moves are there, here also 2 right moves are there, and 1 down moves are there. So can we use permutation and combination and combinatorics method to find the possible number of paths by just arranging these number of R's and these number of D's into anyhow, such that we can get our possible path. So now just our problem is reduced, that R, we have to move either right moves we and or either down. So total number of mandatory right moves will be what? Will be n minus 1. Will be n minus 1. So we have these number of right moves and we have these number of down moves. So now we have to just find permutation of all the possible way to arrange these right and down moves. So what we can do in permutation and combination, we have understood that suppose how many total moves are there. So we can say total moves are there these number plus these number. So total number of moves, we can say this is, if we add these two moves, this will be m plus n minus 2. Now if we have to calculate total number of possible permutations to arrange these R right and down moves, let's say we have to arrange R and D, and we have, let's say, total, let's say we have total m plus n minus 2 spaces, and we have to arrange R and D here. We have to arrange R and D here. Alright, so in how many ways we can arrange these R and D in these m plus n minus 2 empty spaces? So we all know the formula in permutation and combination. This formula is nothing but m plus n minus 2 factorial upon the repetition ones. So we can see that R is repeating n minus 1 times and D is repeating m minus 1 times. So we have to just divide it by the repetitions, m minus 1 factorial and n minus 1 factorial. So now this will be our answer. This will be our total unique paths and this will be our answer only. So we have to just go and calculate this, and we can just easily calculate this either using factorial. We can just define a function factorial, or if we carefully observe, this is nothing but if we carefully observe, this is nothing but m plus n minus 2 c m minus 1, or m plus n minus 2 c n minus 1. So if we use NCR formula and reduce this, we will get this only. So now we just have to calculate either using factorial this, or either we have to calculate this. So what I think, if we use this formula, we have to go and calculate factorial of m and n. So this will take big O of m plus n time complexity, because we have to calculate factorials. But if we go and calculate this m plus n minus 2 c m minus 1, so we just need to write the function for NCR, and we know the optimized formula, optimized function for calculating NCR. This is nothing, just suppose we have to we will right optimized version of calculating NCR. And we all know we have just done this, we have just learned this formula in Pascal's triangle also. Pascal's triangle, if you don't know, you can watch that video also. So suppose we have to calculate 10C3. So what we do, just we go and we keep multiplying 10 minus 10 into 9 into 8 3 times. In the numerator, 3, these number of r number of elements will be there, and in the denominator, up to from 1 to r numbers will be there. So we just we know this is the same. So similarly, we can just write n into n minus 1 into this up to n minus r plus 1 upon 1 into 2 into up to r. Alright, so this is the formula, and now we have to just write this formula, and we have understood the intuition that why this formula is working. And now we will write this NCR formula. We all know the time complexity of NCR is big O of r if we calculate this. So we can just solve this problem now in around big O of 1 space complexity and time complexity. We will see what the loops we are using. Here I can see I am using big O of r, so we can say that time complexity will be big O of r, and r is either the m minus 1 or n minus 1. We will use the minimum of m minus 1 and m minus 1. So let's go and implement this simply. So what I said, I have to just calculate NCR. So in my case, n will be total number of possible this m plus n minus 2. Alright, so total number of possible moves, alright, mandatory moves, n minus 1 right moves and m minus 1 down moves. So total number of mandatory moves will be m plus n minus 2. Now if I calculate r will be either we can use m minus 1 or n minus 1. I am using minimum. I am using minimum of m minus 1 and n minus 1. So this will be minimum of m minus 1 and n minus 1. Now we have to just call the function NCR, and here we will pass n and r, and now we have to just write the function NCR. So this will be returning integer, and here we have passed just n and r. So how we implement this? We just take a result variable as 1. So I'm using long because we will be multiplying here, so this can go out of the integer range. So that's why I'm using long variable, long integer, long type, data type. Now how we calculate this? We just go from I is equals to 0 in the numerator up to the row. What we do in the numerator, we just multiply result by n minus I, because this way only will be written as 10 into 8 into 9. So first, suppose we have to calculate 10C3, so this will be 10 into 9 into 8. So the first will be 10 minus 0, next 9 minus 0, next 8 minus 0. So, and here in the denominator we just multiply it by I plus 1, because into denominator we want 1 into 2 into 3. So from starting 0 I will say divided by I plus 1. Alright, now this will calculate our NCR and we will just return our result, but we have to return the result in integer data type. So I will convert this result into integer. Now we can just run the sample test cases and check also. Yes, sample test cases are running, and now let's submit it and check whether we are able to pass all the test cases or not. So yes, we have solved this problem successfully now. And if I tell you the time and space complexity here also, so time complexity is we are just calling this NCR function, and this NCR function is taking just one for going taking uh, is just using one for loop from 0 to r. So we can say time complexity is big O of r, where r is the minimum of m minus 1 and n minus 1. So approx we can say minimum of m comma n. And space complexity, we can say we are not using any space, so that's why our space is big O of 1. Alright, so this was all about this problem. We have understood that how we can uh, find all the possible paths in a matrix from starting to the finishing point. So I hope you understood. Thanks for watching. See you in the next video.